tempo.
Hi, my name is Drake Collier, and for my ME305 final project, I did a drum tempo monitor. The problem I have is I'm a drummer, and if I don't have a metronome that's playing in my ear, give me a constant tempo, I don't play very consistently. My tempo is all over the place. And so the problem that I needed to solve was to have something that could train me to have better internal tempo so that when I don't have a metronome playing in my ear, I can still play good. So, how does this work? If you come a little bit closer here, you can see I have a sensor that's taped to my drum right here. I have my display. You can see on the display, I have on the top the tempo that it's set at and the measured tempo. And then up here, I even have an analog indicator needle. Essentially how this works is that it detects vibrations when I drum through this piezoelectric vibration sensor. It reads it in the Arduino and it detects the voltage spikes and converts that to BPM, to beats per minute. And essentially I can set this tempo to a tempo that I want to play at, and it'll give me feedback for how close I am playing to that tempo. So right now it's set at 120. If I play around 120, it'll give me good feedback, but if I start wavering a little bit from that, it'll give me bad feedback. And I'll show you how that works. All right, I'm gonna demonstrate this drum tempo monitor working now. Make sure you watch. You'll see this measured tempo that's changing, and you'll also see this indicator needle going left and right with a changing LED color as well as I try to play 120. So you can see as I waver in my tempo, the indicator needle provides visual feedback, both with the LED and the indicator needle going right or left, along with displaying the measured tempo on the LCD. So I get two different ways of seeing how close I am to the measured tempo that I want to play at. And if you come in here a little bit closer, I have an IR remote where I can change the set tempo. So I can change it up to, let's say I change it to 121. I can change it to 125, and now it'll detect a faster tempo. All right, real quick, I'm gonna run through all the components of this. First, for my sensors, right here I have my piezoelectric drum sensor. It does have to be taped onto the drum so that it can be flush on there. So I have my piezoelectric vibration sensor, and I also have an IR sensor. If I pop this lid open in here, you can see it right back there. You can see it flash when I use the IR remote. All right, next are my actuators. Technically there's only one here, but I'll explain in a sec. So right here I have a servo. All this does is it controls this indicator needle. It moves it right or left a certain amount of degrees, depending on how big the deviation is between my playing and the set tempo that I have. Technically in this closed feedback loop, my arm is also an actuator as I am changing with feedback. So I am technically part of this feedback loop, which does technically not make it completely closed. But for this purpose where I'm training myself, it works really well. All right, and I actually have two displays. One that's an actual electronic display, my LCD monitor, you can see it hooked up in there. And then my other one's actually analog. So I have this LED right here that's hooked up next to my indicator needle. And when I put my lid on, this is another display. It provides feedback, kind of like a speedometer in a car, going right and left and changing colors for how far away I am from my set tempo. Thank you for watching this video. It was really great designing this project. It's good to be able to make something that goes along with my passion of drumming. A lot of the knowledge that I learned from this will definitely be applied into future projects that I make. Thank you.